So in my documents folder, I'm going to create a folder called chat because I want those two files to be in the same folder. So I go to right click new folder and I'm going to call it chat. You could put this wherever you keep your Python files, but I put it in its own folder because there's two files that go together. If all your files are in a big long list of 500, you'll want to start making folders and dividing things up because otherwise, how do you find anything? I'm pretty good at organizing my folders and I still can't find things sometimes. So the best way in Visual Studio Code to work is to open the folder. So right click on chat, show more options because I'm in Windows 11, then open with code. If you don't have the open with code button, then you would probably want to go back to the original early installed Python because you have to click in and add the things in order for Visual Studio Code to do that. If you don't have that, you would go to your file menu and open folder. That's the best way to work in Visual Studio Code because it creates like a little temporary project. Well, the next step is to create a couple new files. We're going to start with our chat server.py file. And while I'm at it, I'm going to right click a new file. This time we need a chat client. So this is going to be a client server application that we're writing in Python. And in class here, we can chat across the room. At home, you can chat from here to here because we can run both of these independently and you can chat on your own computer. The next thing we have to have the socket library from Python. Socket library allows us to make TCP/IP connections. Without that, we can't make a connection. Now, what is a socket? Well, a socket is a specific spot on a server that you're going to connect to. So let's just say your server was 192.168. Oops, that's a .1.10. That's your server you're wanting to connect to. Is the port. So a port and an IP address together make a socket. And you use a socket every day when you're surfing the web, when you go to Blackboard, when you go to wherever you're going, Facebook or TikTok or whatever, you're using a socket. However, the type of socket we use most often is :443. When you're doing encrypted web communication, you're making a connection to the server on port 443. Well, we don't have to type that in because the web browser automatically adds that on for us. If we had to type in :443, who would ever get to a website? Because who can remember these numbers? But that's automatically in there. So every connection you make has this, of course, is a host address, which resolves to an IP address : the specific port number. Now, the server port number never changes. So what if one day Blackboard was on 443 and the next day they decided they're going to be on 444? Well, that wouldn't work. You can't have server IP addresses and ports moving around. They have to stay in the same spot. Client, on the other hand, is a different story. So we're going to create a constant for our server IP. And right now, blank just means it's our local computer. Or you could put in, because that is the address for the local host. That's your local feedback, loopback address. It's for testing only. If you can ping that, your network stack of stuff is functional. All right, and we're going to later on change this to Riley's computer so we can chat with Riley or whoever we want to chat to. All right, so now we need a port, and this is not an assigned port. This is just a port I added. I just put port 8081 because typically it's not used by anything. If you have a conflict at home, you can do 8082, 8083, keep going until you find one that doesn't conflict with something else. You'll find out if it conflicts when you run the program and it doesn't work right. Well, and it says something about port already open or something like that. All right, we need to define our main function, which is the entry point to our Python programs. It's also, main is also the entry point for lots of other programming languages. And then we need to call our main function at the end. Well, let's create a server socket. So a server socket is listening all the time for someone to knock on its door and it'll say, yeah, what port do you want? And you say 8081, and then the server says, okay, come on in. So we have to create that listening socket so that it's listening and saying, okay. Now we have to say what kind of socket. Well, AF_INET is a TCP/IP version 4 address. There's also version 6. So these are the two types of IP address schemes or classes. And we do a comma because we have more than one argument. This is an argument going into this OOP, right? Right now we're talking about OOP earlier. This is a class. Socket's a class. This is an object that allows us to work with all the code that's in the socket class. And then we need to set another parameter, socket.sockstream. Does anybody remember what sockstream is or means or anything about it? Sockstream means that it's a TCP connection. I can't remember what UDP is. I think it's this one. Yeah, sock dgram. Because a UDP socket is considered a datagram, meaning you're just doing your best effort to send it, and hopefully it gets there, maybe it won't. Who knows? But a sock stream is TCP, which means we are guaranteed communication. We do handshakes and all this kind of stuff. And if it doesn't get sent right the first time, we send it again. All right. Now we have our socket. We need to, they call it bind the IP address and the port to that socket. So we do server socket, because that's our object now, contains all the code necessary to make a connection, dot bind, and that's what it's called. It's like connect to, or, you know, make it part of. And the two arguments we need is what is the IP and what is the port. We have our socket created. We're ready to start listening. Well, guess what's next? Server socket.listen. Because it will listen. It's listening for somebody to connect. Now, just to let us know with some feedback, excuse me, because otherwise you won't see anything on the screen. We're going to print saying that we're listening for a connection. So we're going to use an F string. Whoops, the F's in the wrong place. We're going to say listening for a connection on port, and then we'll just put in the port variable, because it's always going to be listening on the same port. It's going to be listening for someone to knock on the port 8081 and say, hello, I want to come in and have some pie, or whatever we're doing. Who doesn't like pie? Well, if somebody connects, we have to accept the connection. And there's two things that happen when we accept a connection. We get the IP address of the client. We also get connection information from the client. But really, we only need the address. But we have to return both of these because that's part of how the library works, which is part of the accept method. I mean, once we accept it, we get the socket information and the address info, which is really what we want. We want the address. So once we have the address, we would say print, because we want to see it, otherwise we won't know what's going on. We'll say connection. Get rid of that thing. There. Connection from, and then we put in the address variable. That's the one we care about. And then you'll see that every time somebody connects, we get a different address because the client port is dynamic and the client address is dynamic. It's always going to be different, but the server is the one that can't change. When you make a connection, part of what's exchanged is the client IP address and the client port. That's how the server knows how to return communication. And we'll just put that address in there. And then we go to whatever's next. Oh, we need a while true loop because we're going to talk for a while. And then we stop talking when we're done. I mean, what good is a chat server if you can only say, do one message, which that might be all we can do with this. I don't know. We'll see. I haven't run this for a while. So while means that we're waiting for an exit condition, meaning something to cause the loop to stop. True means this loop's going to go infinitely, forever and ever and ever. Well, and when we're done, we just would do a Control-C to break it. Anyway, we are going to get from the connection object. Oh, we are going to use that because that's where the information is. Sorry. Data equals, we're going to assign the connection, right? Because that's where the information is. We're going to receive, but on a network, if it's a big piece of data, you can't receive it all at once. 1,500 bytes is the largest that a Ethernet packet can be. So if you have a 3,000 byte message, it has to be sliced into 2 pieces. And that happens at the transport level, because the transport level is the part that takes all the packages off the FedEx and then actually distributes them to each house. It's like what the driver does. So we're receiving it, but we have to receive less than 1,500. So we're doing 1024. That's called a buffer size, which means it's a temporary place in memory. We're going to store those 1024 bytes, and when we get some more, then that memory gets shuffled away. Now, what goes across the wire is binary information. So it's ones and zeros, and I don't know who can read ones and zeros and come up with a message or not, but I don't think I could.
You would have to decipher it.
Yeah, which is actually the decode. It's called decode. So it's decoding the binary into what's called UTF-8. It's one of the current standards for how text. So now we take our binary data, decode it into text, and our data now has text that we can read, or a string. Wow, listen to that. Well, the next piece is we have to have some way to know, is there actually data coming in or not? And we also need, we also need a way to exit. So we can also then start listening for another client, because our chat server only can service one client at a time. We'd have to do threads or something like that, which is way beyond the scope of this course. What this program is designed to do is help you understand at a low level what actually happens when you make a connection and send messages back and forth. Otherwise, it's just theoretical. Well, it's not theoretical when we use packet tracer, because you can see the little packets going around. All right, so if in data, that's not right. if data is equal to Q. That means we've typed in Q for our message. That means we're going to quit. We're going to close our connection. The server is going to close the connection. And that does housekeeping and closes up those resources. And now we need to print a couple of things. We'll just say client disconnected. And then we're going to copy this from up here because now we're listening again. Since we can only service one client at a time, we have to close the connection with one client to be listening for another client again. Then we're going to do this business. So I could have taken all these lines because when we make a connection, it's the same process. We're listening on this port. Somebody connects on that port. We get an address and connection, and then we print that we have a connection from that address. So this, how we connect, happens the same way every time we connect. However, if the data, which is else, if data contains something else, well, then we receive it. We print the message. So we need an F string, and I'm gonna put a couple of these. That's supposed to indicate like our little chat interface, and we print the data. There. So this prints whatever is coming in from the client. And then we wait for some input from the server, because our server is also participating in the chat, which isn't typical. Servers usually don't participate in the chat, but we are, just because our server is going to behave like a client. Because we don't have enough to do two clients connecting to a server. Then again, we need threading and stuff, which is more than we want to do. Then we send the message. So we still have our connection, right? And there is a dot send, just like there's a dot receive. And we send our message. Well, our message is in what kind of data format? What sort of data format is our message in? We've typed it in the screen. We've got input into a variable. What type of data is that? We typed it in from the screen, from the console. Anything you type in is string, always a string. You can't type in a binary message into almost any program. We can encode it. And we do the same UTF-8, just telling it that, oh yeah, this is text, but we're going to encode it to binary. So now we're sending binary information. And then on the other end, the client does the input and receive and converts it, decodes it, and all that kind of stuff. All right, that's the client. Sorry, the server. Pause. We can test the server by running it, because even though there's no clients, it should still run without giving us errors. And socket object has no attribute list. What? I must have typed something wrong. It says on line 15 something's wrong, so I must have typed something wrong. It's this one. What did I do wrong? Well, it says something about a list, but server socket data accept equals connection address equals server socket. We're listening. Oh, you're right. Thank you, Hope. Somebody typed in something else. LISEN. There. Let's try that again. Listening for connection on port 8081. Well, unfortunately, my server is going to be listening for a long time until somebody codes their client. In the meantime, we're just gonna stop it. Time to make our client. Well, this is gonna look kind of familiar. Import socket. We need to know the server IP. We'll change this later to whatever the IP address is of whatever the computer is. And now I remember you don't have to specify a server IP because this just means the local machine. We don't have to specify anything here. I think that's right. All right, so we know this is who we're connecting to. We'll change that IP address later to somebody else's in the room when we try this. And what do you suppose the port's going to be that we have to have?
8081.
Yep, we have to specify the port of the server or we're not going to make a connection. We have to specify the IP address and the port of the server because we're making the connection. The server is listening for a connection. We have to be on the same port. Well, much of what we're doing next is going to be very much the same. So I'm going to take everything from here on down and copy it and just change what I need to change because much of this is the same stuff. So copy it. I used Control-C to copy. I'm going to paste that in here and we will just modify. We do need to create a socket, but this time we're going to create a client socket. One of the handy things that I like to use, and that's true of many development environments, is if you press, some have a different key in Visual Studio Code. If you press the F2 key, I can modify this. And when I press the Enter key, it renames everything, but you have to modify it. You can't delete it and then type in something, otherwise it won't work. When I press Enter, not changed every time I say client socket. That's very convenient. So the client socket is just like the other one. It's going to bind to the server IP and the port because that's where we're going. Are we going to be listening? No. We are going to be sending, so we're not going to listen to anybody. In fact, we're going to take all of this out because we're not going to listen and get a connection. We are going to make a connection. So this is going to change. We need to get the message from the user. So we are going to do input. Forgot my little parenthesis. We're going to say client. And that's going to prompt for us to type something in. If message, what did I do wrong?
No, I said
Oh.
if message.
Right, if message equals Q. Okay, I thought I did something wrong. Okay, so we're not going to have any listening or anything like that going on. So we are going to take all of this out. Unfortunately, we kept the shape of the code, but not so much exactly what we're going to do. So we take our client socket, and this time we send, like we did on the other end, message, right? Dot encode. And then we're going to encode it the same way because we're converting text to binary. And we send it. But we're only going to send one message. We're not going to repeatedly send a message. After we send our message, we're going to do client socket.close. So we're just going to send a message and then we quit. Yeah, I know. Not very exciting, but it takes more programming than we know to like repeatedly send messages and all that. This is just a very simple chat. Well, oh, sorry. This is us sending a queue to the server. I said that all wrong. This is sending queue to the server. And then it closes the connection on that end, we close our connection and we quit. Else, if it isn't equal to that, then we have client socket dot send. Oh, we just did that up here, didn't we? Yeah, this guy right there. We're going to send our message to the server. And then we're going to receive our message. This is going to be a response from the server. So we have client socket.recv 1024, so that our packages of information match in size. And then we print our decoded message. And we can send more than one thing. All right, print F formatting. And we put in a couple of these guys indicating a message is coming in. Curly brace, message. Because the message coming in is binary, so we have to decode it. And we use UTF-8, which just represents it's a Unicode for a simple string. And there we go. Now, if we run our client right now without the server, it's not going to work. Or nothing's going to happen. Yeah, we're going to get a big error because there's nobody listening for us to talk. So that's not so good. So for a client server environment, the server has to be running first. Let's take a pause for the. So to run this in two separate console sessions, we go up here to this little down triangle, and we're going to run the Python file in a dedicated terminal, which means our server is going to be running all by itself in its own terminal. And there it is, it's listening. Now, yes, you guessed it. We're going to have our chat client do exactly the same thing. We go to our chat client and we run this one in its own terminal. There. So this guy is running, this guy is waiting. So let's send a message. Hello, how are you? So our socket connection is established. The server is waiting for us to make a connection. When I press enter, my string is going to get encoded into binary. It's not going to be sent over the wire because we're doing it on the same computer, but it'll be sent over to the chat server. It'll be decoded into a string so we can read it on the other end. So let's press enter. Uh-oh. It says it's not connected. No address was supplied. What? All right, let's take a look at this and see what I did wrong. Everybody else's client is working. I'm not sure why mine isn't. They have their own laptops. There's something about my computer that's one of the classroom computers. I don't know, I'm gonna test it out. Anyway, Riley's and Dylan's and Hope's are all working. I've got my server running and I'm going to type in ipconfig and Riley is going to connect to me. My IP address is at 10.0.1.151. So you would change your chat client to say 10.0.1.51. Oh, maybe I should try that. 10.0.1.151. That's my computer's IP address. And my server is listening. So when Riley types in a message, it should respond, we hope. All right, well, it worked. I'm not sure what happened. I think he typed in maybe the wrong address.
Yeah.
Okay.
Wait for you to respond.
So then the connection came in from this IP address, that's Riley. And this is the port that he came in on. So now my server knows to communicate back to your computer and port, because you have to communicate socket to socket. Mine's not gonna change, but every time somebody connects, it's going to be a different port. And I'm going to say, hi, Riley, let's let Hope try it. And so you should get the message. I hope. Did you get it?
Yep.
Okay. And so then you'd type in Q, because you're wanting to end your session.
There it is.
Okay, and I should switch over to listening again. Maybe I have to type in Q also. Oh. An existing connection was forcibly closed. Well, I don't know what happened there.
I think it's mine. I was trying to say.
Ah.
I chose the same message.
Hope, you wrecked everything. Okay, Hope, I had to restart my server because of you. All right, go ahead.
Me?
Yeah.
Okay.
10.0.1.151. Yep, see, it's a different port than what Riley had. This is 65142. This is 16038. So you can be somewhere in like this area, clear up to 65,000. Your client randomly picks a port. Well, who is me? How do I know it's me? Oops, I typed in wrong. I've typed in my program. I'll type in the famous song from the Who. Who are you? Who? That's like a very famous song. What was that? I mean, it was famous before it was on like those NCIS things or something, or whatever that is. It's Hope. Oh, well. Why didn't you say so? So theoretically, if you type in a Q, it should quit, and then we can get Dylan in on this. Because apparently I can't do anything until you send me another message, Hope. Or I have to just kill my server.
Okay.
Or did you type in Q already?
Do I have to?
I'll see that, or I have to kill my server and start it out again. This is not a very robust server. So I'll kill it. Okay, Dylan, are you ready?
Yeah.
All right, let's bring up a connection for Dylan. Listening for connection on port 8081.
And then chat client.
Yep, and you would be, your destination on the chat client is going to be 10.0.1.151.
Oh, wait. Let me see.
That's who you're connecting to in your client. Because I'm always going to be in the same place. Everybody else can be in a different IP address and a different port, but because I'm the server, I have to stay put.
So because we're doing it this week, we don't have to run our chat server, right?
Do what?
Do we have to run our chat server? No.
Oh, you already did it in class.
No, because we are communicating with you.
Yeah.
We don't have to run our own chat server.
Right, because I am the
Our
server.
Okay.
Yep. I am the server.
Okay.
No, I lost my piece of paper I've been writing things on. Okay, Dylan was never going to connect to me. He doesn't like me anymore.
I don't know why it's acting like that.